Oops.
I remember he used to play with the don't make my small cake.
All right, let's get out 11B. I got
I don't want to be here. Like on accident, like you're gonna mean to. Just walk up to them during the play or something. You are sure. Oh, I'm so sorry.
That is not enthusiastic.
How's yours, Ryan?
Awesome.
Wait, dirty, boy. Play a little dirty.
All right, 11.
Guy that was just like.
11B. What questions do you want to see? Got time for just a couple.
And then I was just like, I barely make them just like, bro, I'm so sorry. Like, and they just, oh, you're fine. You know, just,
Questions on 11B.
it wasn't as good as it was.
After this one,
It worked.
Oh my God.
It just wasn't good. If it's on the long term.
going once on 11B.
Wait,
Yeah.
wait.
You don't want to get a red card.
Whoa, wait.
When you're throwing the extra, you have to wait until after the party is over, and then the ball's out. The ref is looking at the ball, and then that's when
Do it. Take a video. That's someone's video.
I can't take a video while
Have someone else do it.
Strap on a GoPro.
Yeah.
Where's Coop been? Where's that dude?
Going
to Alabama today. Called him.
You know what?
I was just on the phone with him.
Is he getting pancakes for us all?
Going to Alabama.
Alabama.
I don't think so. I don't think they have pancakes down there.
Are we good? No questions on 11B?
What do you do, 11?
11.
Is he playing Leonard Skinner?
Sweet on Alabama. I like it. All right.
It was just evens, right?
Yeah, it was just evens.
Oh, man.
But I can do 11 no matter what.
Oh, sorry.
It's not going to hurt anything if we see this. So all they want us to know is what would a common denominator be if we were to do these. So this one has an x and it has an x minus 7. I need to factor this out to give me x minus 7 and x plus 1. So my common denominator would be x, x minus 7, and x plus 1. And I'm not too worried about the numerator because we're not adding it. What else would you like to see? 14. 14. Don't worry about that one.
What? You sold it?
We're good? Going once?
Okay, 14.
Don't worry about it.
Oh, you do 16.
16, negative 4 over 7x minus 5 over 3x. Okay, so both denominators have an x in it. The number that both 7 and 3 have in common is 21, so I get 21x is my denominator, so I have to multiply this top and bottom by 3. That becomes negative 12 minus, and then multiply this by 7 and 7, 35. And then you can combine those, so I get negative 47 over 21x. Check to see if 47 reduces with 21. It doesn't because 47 is prime.
26.
26.
This is a fraction of a fraction.
Fraction of fraction. I love it. Okay. Fraction over a fraction. So let's take care of the top first. So I'm going to make this 4 over 4. And that's the same thing as 1. So 4 over 4 minus 1/4 is 3/4. On bottom, I'm going to make this 24 over 8. So multiply top and bottom by 8 over 8. 24 over 8 is indeed the same thing as 3. So 24 plus 3 is 27 over 8. Fraction over fraction, multiply by the reciprocal of the denominator. So I get 1, 2, 1, 3. So 1 times 2 is 2. That should have been a 9, excuse me. So 2 over 9.
Nice.
Time for one last one. Yeah. 12. Got it. Okay, so let's figure out our denominator. Let's factor each of the denominators. So that'll factor to x minus 7 and x plus 4. Is that okay? And then the other one, we'll factor this. That'll go x plus 2 and x plus 4. So we have a single x plus 4 on both. So x plus 4 is going to be part of it. We have an x minus 7, so that'll be another part of it. Take care of it, and then we have a x plus 2, so that's the last part of it. And again, we're just trying to find the least common denominator, but you have to factor them to get there. Good. All right, make sure your name's on that, as well as anything else you might be handed forward. A lot of you didn't hand in 11A, so if you have that, make sure you hand that up as well, please. 11A and 11B.
Oh, no, wait. Because we have these. Yeah. Start, watch them do separately.
Sleep. After this class.
When is the class 10?
28 is when the class ends, and I think at 40 the assembly starts.
¿Qué?
10:40. This class ends at 10:40.
Gracias. Al menos no me dicen Eduardo.
Man, it's almost the weekend. We just gotta make it to.
We'll make it.
Thanks, bro. Yes, sir. I'm not gonna take it.
Do you want something?
Oh, did I?
You handed in that. The extras. That's okay. All right. Not too tough of a lecture today. Should be able to get through it, I hope. All right. So we're going to start solving these. So problem number one, first thing to do, the best skill that you need to really get down pat is clearing denominators. So on this first one, if I multiply all of my terms by 6, this becomes a 2 and an x. This becomes a 3, and this becomes a 60. And if you just clear the denominator, things are going to work out really nicely for you. If you don't clear the denominator, that's 57 over 2. If you don't clear the denominator, you might start running into some goofy problems. Now, when I say clear the denominator, we can clear the denominator with letters and stuff and expressions. So this one, I have two sides. I have this side and this side. I'm going to multiply both sides by 8. So this is going to cancel. Distribute that 2 over, so I get 2x plus 10. And then those cancel, equals 3. And just simply solve it. And we get that for an answer. Seem okay so far?
Yep.
Everyone happy enough? Yep. All right. All right, so now we have letters in the denominator. So I want to clear our denominator, but things that we have to kind of think and keep in mind on this problem. Right now, I know no matter what, my answer can't be x equals 0. Okay? Does that make sense? Why?
Yeah, you can't have a 0.
Yeah. So I'm going to multiply all 3 of my terms by 2x. And then reduce what will go out. So x cancels x, so I get an 8 here. Plus 2 cancels in the 2, so I get plus 5x here. X goes into x, so I get negative 22 there. Does that math seem okay? Subtract 8 from both sides, so I get 5x is equal to negative 30. So I find that x is equal to negative 6. Make sure your answer plugs back in and doesn't give you a 0 in the denominator, and it doesn't, so that works. This is a far easier way than getting a common denominator, adding them together, and trying to solve it. This method will allow you to really go through these problems quickly. All right, so I have three terms. I have 5x over x minus 2 as one term. I have 7 as another term. And I have 10 over x minus 2 as a third term. What do you think I should multiply all three terms by? X minus 2? I'm going to multiply by x minus 2. And notice I'm not doing it at the top and bottom because I'm clearing the denominator. Okay? So this will cancel this. That leaves me 5x. And then you need to know that x can't equal positive 2 because of where that's at originally. And then this is going to cancel here. So, oh, wait. That cancels there. So I get 10. This would distribute 7x over this. So I get 7x minus 14 plus 10. 14. All right, so I get 5x equals 7x minus 4. Let's bring this over so I get negative 2x equals negative 4. And x equals 2. What did we say in the beginning? X can't equal 2. So this is an extraneous solution. So this doesn't work. If I plug this back into the original, I get an undefined term. So I get no solution, or some of you like doing the empty set sign. Either one's totally good. Problem number 5. Let me see if I can bring this down a little bit. I just moved it down for us. All right, for this particular problem, does this factor to x plus 1, x minus 1?
Yeah.
Yes. So we have to keep that in mind. Also keep it in mind, we know that x cannot equal 1 and x cannot equal negative 1 because that would give us a 0 in the denominator. So I keep that in mind. So I'm going to multiply all three terms by x plus 1, x minus 1. All right, so let's reduce. This is gone, so that leaves me x minus 1 and then 4x plus 1. This entire thing cancels that, so I just get equals 12. And then that's just going to be plus 3 times x squared minus 1 if I FOIL it out. So let's do our multiplication. So 4x squared minus 4x minus 3x minus 1 equals 12 plus 3x squared minus 3. Let's solve that. I'm going to bring 3x squared over here by subtracting it, so I get x squared. Okay, so that's taken care of. Combine that, I get 12 minus 3 is 9. Add 9 over here. So I'm going to get 8. And the minus 3x stays right there. Let's see, did I do all my math right? I think I did. If I can't factor it, what do? I'd like to say we complete the square, but unfortunately we don't. We do x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Right? Remember that? You're like, dude, I have to know that again. Yeah, sorry. All right, so negative 3, so I get 3 plus or minus negative 3 squared is 9 minus 32 over 2. So I get 3 plus or minus root negative 24. All right, who remembers their imaginary numbers? So I get 3 plus or minus I root 24 over 2. I can reduce root 24 down to 4 and 6. 4 is the biggest perfect square. That gives me 2I root 6 over 2. And then I can reduce it. Nope, don't reduce it. Oh. Okay.
23, not 24.
It is. Beautiful. That makes our answer right here then. That's a 23, and that's my answer because that won't break down. And so I guess we should put 3 plus or minus I root 23 over 2, and that tells us we have 2 complex solutions. Yeah.
Could you go back up a little bit? A little bit more. Do you see that part where it says 12 minus 3, and then that'd be 9?
9.
When do you subtract 9 to the other side?
We
That'll
do,
make
and
a
oh my
-10.
gosh, and that's a negative 10, and I totally screwed this problem up because then this factors, oh man, I was hoping that would be the case, but so I get this and this, so I can find that x is equal to 5, and x is equal to 2, and what did we say x can't equal to in the beginning? 1 and 1, so we're good. So all of this other stuff down here, this is all wrong. Because your teacher can't do basic arithmetic, that is what you get to. And I'm sorry that I have a phallic symbol up on the
It's the best kind of symbol.
Okay.
All right. One of these days, I'm going to learn how to do math really well. Might be when you have your grandkids come through, but it's like, man, Sturp, he's like 94 years old. Do you still tell that orange story? Yeah, and his teeth fell out when he started laughing. Actually, if I'm still teaching at 94, that'd be kind of cool. At least I'm doing something, right? Help me out. What do you think? I have 3 terms. Agreed? I have x, and then I have x plus 1, and I have x. What do you think I should multiply all 3 terms by?
I think we should just leave it.
Nope.
X plus 1.
Yeah, x and x plus 1. X and x plus 1, all 3 terms.
So isn't that just x squared plus x?
So that's gone. So that's 3, yeah, 3x plus 3, but you don't want to multiply it out because you want things to cancel like this.
Oh, okay.
Minus 2x. That cancels that. Equals 4x plus 1. Alright, so I get x plus 3 equals 4x plus 4. Subtract x, that's a 3x. Subtract 4, that's a negative 1. So x equals negative 1/3. If I had plugged this back in, I don't get a denominator that is 0, so that's my answer.
Nice.
If you had graphed this, the left side and the right side as y1 and y2, you would find they intersect at x equals, well, it'll show up on your calculator as negative 0.33333. But that's what we would do. This one, is this the difference of 2 squares?
Yeah. 2x plus 3.
Yep.
2x minus 3.
Good. Minus 3, squeeze in there. Okay, what do you think I should multiply all 3 terms by?
2x plus 3.
Yeah, so let's see if you can follow me along here. Okay, I'm doing this without a net right now. Plus 3. Yes or no?
Yes.
So I multiply by 2x plus 3 and 2x minus 3. So on the first one, that means the 2x plus 3's cancel out, and then you have to multiply 5 with 2x minus 3. On the second one, you have to multiply by 2x plus 3, 2x minus 3. The 2x minus 3's cancel out, so you have 4 times 2x plus 3. And then on the third one, 2x plus 3 and 2x minus 3 cancel out. And so let's see if we can clean this up a little bit. So I'm going to get 10x minus 15 plus 8x plus 12 equals 14x plus 3. That's just algebra 1 all day long right there. So I'm going to get 18x minus 3 equals 14x plus 3. Subtract 14, so I get 4x over here. Add that, so 6 over here. X equals 3 over 2. Let's double check. If I plug 3 over 2 in here, I get 3 plus 3, which is 6. I like it. If I plug 3 over 2 in here, 2 times 3 over 2, that's 3 minus 3, which is... Well, what happened? We have a no solution again. Or the empty set, okay? Does everyone see why it doesn't work? 0 in the denominator is a big no-no.
3x equals 2/3.
If you graph this on your graphing calculator, your two lines or your two graphs will not cross each other. Just no solution.
Oh.
Because if I plug 2/3 into that second one, I wind up getting 2 times 2/3, which is, or 2 times 3/2, which is 3 minus 3, which is 0. How much more? Dude, are you serious? You got that much more? Are you kidding me?
2 reading pages.
Hey, little trick here. What do you think x squared minus 6x plus 8 factor down to? I have them underlined up there. Okay, so I'm going to multiply all 3 terms by that. So it cancels out on the first. Does that make sense? On the second, I get this. On the third, I get this. Do you agree? Nobody stuck on that? Okay, do the math. 2 equals x minus 2 plus 2x minus 8. So I'm going to get 2 equals 3x minus 10. Add 10. So x equals 4. Help me out. Help me out.
No.
Why?
Because 4 minus 4 is 0.
Yeah, that's going to be goofy. No solution. Empty set. I don't know if we're doing a whole lot of no solutions on this just to show that it does happen, but I don't think tonight's homework everything will be no solution. Judging by our notes, though, you probably have a pretty good chance to put no solution and getting a few of them right. All right, this factors to x plus 1, x minus 1. So, not really showing all the work, but I have this. To get that. And then work this out. So I'm going to get 5x squared plus 5x minus 2x squared plus 2 equals 14. Please don't be a no solution. So I get 3x squared plus 5x minus 14. Oh, it factors. What do you think it factors to? 7 and 2. Okay, let's see if we can do that. 3x and x, I agree there. If I do a 7, someone else says it's going to be 21. 2, 6. Oh, maybe? No. That factor?
You see the 2 up there? Next to 14, does that bring down? Does that come down?
Oh. Yeah, that 2 came down, didn't it? Dude! When I subtracted that over, that means that's a 12, isn't it? Well, I didn't get too far ahead of myself. Thank you. All right, so let's see. 4, 3. Does that work? No. 4 here. What do I do? A 4 here and a 3 here. That's 4x. Nope. What about a 6 here and a 2 here? Let's see. 2x. 18x. That's too much.
What about you switch the 6 and 2?
Well, then I have a GCF here. 2, 1 and 12. 12 in there? 12, no, it's not gonna work. Boogers. All right. I made a mistake there.
You just give up.
Yeah. So you all know this, I believe. That's 10 over 3. That's pretty simple. And then when we start getting ugly with these, like, is there any down here? It was. All right. All right. Common denominator just on top. We're going to go 3 over 3. So on top I get 3 plus x over 3.
Good morning, students. Please pardon the interruption. Just a note, we don't want you to worry about bringing anything down to the assembly, so please leave your backpacks and any personal items in your classrooms. The rooms will be locked and secure, so after the assembly, you can come back and pick them up there. Again, please don't plan to bring any backpacks or personal items to the assembly. They will stay in your classroom, and we'll make sure everything is locked up and secure. Thanks so much. Bye.
Cool. All right, everyone feel comfortable with what I did so far? All right, so if we just multiply these out, we're not solving for x, we're just multiplying. So I'm going to get 6 plus 2x over, so I'd multiply here, and then I'd get 6 minus 3x, and that looks pretty.
Those 6 cancel.
Nope, because it's a term. You have to be the whole term, not just a 6. All right. Was that the same problem I just did?
Yeah.
Sweet, I'm done. Hey, do you guys want a lot of homework this weekend?
No.
Okay, we'll do a lot. All right. So, let's do this. Let's see if we can figure this out. We're going to do worksheet 11C EOE. Every other even. So start with 2, skip 4, go to 6, skip 8, go to. Make sense?
Could have checked that.
Did it?
Yeah, because if you do -4, that'd be.
What is that? Hang on, I'll go back to it. That one?
Yeah.
What did it come out to?
3x minus 4.
Minus 4?
Yeah.
And
X plus 3.
X plus 3. So, oh, that's 9x, yeah. Oh, here, we got it right. All right, so x equals 4 over 3, and x equals -3. That's that answer on this one. Any of those? They both work. Yay! Thank you, Jorge, for making that work. That was that one problem I goofed up on. It factored to 3x minus 4, x plus 3. I feel better about myself already. And I got done quick. Hey, does everyone understand every other even? Is anyone stuck by that? If you don't understand every other even, do all the evens and you'll make sure you nail it then. So I guess we'll leave our